Hello everyone, welcome to this class. And in the previous class, we talked about work and energy. And we said that the amount of energy you do determines the work you'll be able to perform. And in the last class, we said that work is done whenever a force moves a body along a distance. So in this class, we are going to be continuing from where we stopped. Before we continue from where we stop, we are going to be defining the unit of work. The unit of work is in joules. The unit of work is in joules. I write that down. The unit of work is in joules. Denoted by G. Same with energy. And work is a scalar quantity. Work, energy are scalar quantity. Alright, so in this class we'll be talking about power. Also note that you can have kilojoules, you can have megajoules. And you know what this means. Kilojoules is joules times 1000. Bodies are covered under measurement fundamental units. Alright, so in this presentation, all we are going to be doing here is power. What is power? Imagine I have the same energy like my classmates, and we are being asked to perform a task. Both of us have the same amount of energy to perform that task. But what happens is that my classmates perform the work faster than me. In this case, the difference between two of us is that one of us have more power than the other, right? So power, we can say power is quantified by how fast you can do work. So we can say power is equal to the time rate of doing work. So that brings us to work over time. So power is the time rate of doing work. So power becomes work over time, right? So that implies that power is equal to force sorry we know that work is equal to force times distance, right? I want to derive another formula from this so that we can enjoy the class. We know that work is equal to force F times distance. And power is equal to work over time. So if power is equal to work over time and work is force times distance, so if we get power from this side, that will be force times distance over time, right? And from here we can see very carefully that we have x at the top of the fraction and we have time at the bottom of the fraction. And from our kinematics, our equation of motion, we know that x over t is the same thing as distance over time, right? And distance over time, which is displacement over time, is the same thing as what? Velocity. Because velocity is the change of distance over time. So everything here is the same thing as velocity, right? And if we take this multiplication side to this side and we bring this f to this side, it implies that power also is equal to what? Force times velocity. So another formula you should know for power is force times velocity. Alright, now You should understand that power also is a scalar quantity, and the unit for power, unit for power is in watts. Unit for power is in watts, and the watt is spelled W-A-T-T-H. So the unit of power is in watts. Also, the way we saw kilojoules, megajoules, and power also is measured in kilowatts, megawatts, gigawatts, depend on the quantity we are looking for. But in O-level physics, we restrict ourselves to watts.